This is a question from the study plan 8.2.17, and there's a hard copy attached, and I'm going to do in this video the first part, finding the p-value, where we're given that the claim is that the proportion, some proportion, is greater than 0.8. So this is the claim that we want to test using a hypothesis test. The test statistic was already found for us. It is z equals 1.41, and we're supposed to assume a significance level of 0.05. To understand this problem, we need to first construct our hypotheses. What does a hypothesis test look like? Our claim, the thing that we want to determine is whether the proportion is greater than 0.8. Now, the opposite of that would be, if this were not true, then it would be p is less than or equal to 0.8. But since the alternative hypothesis, which we represent as H sub 1, is the hypothesis that does not contain the equality, we use p is greater than 0.8 as our alternative hypothesis. So our claim, the original claim, is the alternative hypothesis. The null hypothesis always has the equality. It's the one that's equal. So the null hypothesis is that the proportion is equal to 0.8. We know that this is a right-tailed test because of the inequality symbol, which says that the proportion is greater than 0.8. So the right tail is the red shaded region that you see. And our test statistic here, z equals 1.41, is at the borderline of this shaded region. Now we are asked to find the p-value for this test. That means we're trying to answer the question, what is the probability of getting a test statistic at least this extreme? At least as extreme as z equals 1.41. That is our test statistic. So we're trying to find that p-value. When I look up the area of this red shaded region, I have to remember that the table A2, does not provide areas to the right. So this area that I obtained in table A2 is the area to the left. It's actually this area over here. To get this area to the right, I have to subtract this from 1. And that area is 0.0793. That is the area of the red shaded region. And this is what the p-value is. This is our p-value. It's the probability of getting a value for the test statistic, at least this extreme. Now we're asked to test this hypothesis at the 0.05 significance level. This alpha equals 0.05 is the probability of rejecting the null hypothesis. This is the null hypothesis, H sub 0. It's the probability of rejecting it when it is true. That's about 5%. It's a pretty low probability. So we're performing the hypothesis test at this level. But our p-value is 7%, about 8%, 0.0793. So that p-value is too large. It's not, it's 7%. There's a higher probability of rejecting the null hypothesis when it's true. So we fail to reject the null hypothesis. And we do not have enough evidence to support our claim that the alternative hypothesis, p is greater than 0.8, is true. This is an example of using the p-value method for performing a hypothesis test. And this was a right-tailed test because p is greater than 0.8.